Hey guys, what's going on? So to open up, we're going to start out with some basic geometric terms, some symbols, some labels, and some notation. Some of this might sound a little bit familiar, but some of it might be a little new. And this is some things that are essential and important for the whole course. This is not just going to disappear after we first go over it. So this is going to be coming up throughout the year. So you are expected to know it comfortably. So let's start out. So after this lesson, you should be able to graph ordered pairs, identify points, lines, and planes, identify and draw models of points, lines, and planes, and identify collinear, coplanar points, and interesting lines and planes, or intersecting lines and planes. Sorry, that's a typo. So what is the origin? The origin is the center of our coordinate plane here. We have the two axes that are crossing, and right at that center, 0, 0 is our coordinate for that. That is the origin. So you can think of it as the center there, okay? And then we have our axes. So we have our x-axis, which is horizontal. And then we have our y-axis, which is vertical. So we have, just to repeat, we have our vertical axis, which is our y-axis, and our horizontal axis, which is our x-axis. Okay? Now we have our quadrants. And now, this is something that can be tricked up easily, so it's important that you pay attention to this. And remember, it's always counterclockwise, starting from the top right. So this is our first quadrant, our second quadrant, third quadrant, and our fourth quadrant. So something that I always like to do when I am looking at the coordinate plane and looking at the quadrants is I like to label the signs of the coordinates in the quadrants. So any point that's in the first quadrant will have a positive, positive coordinate. Over in our second quadrant, it will be a negative, positive coordinate. Our third quadrant is our negative points. And then finally, our fourth quadrant is our positive, then negative points. So that's the basics of our coordinate plane. And the coordinate plane is really just the combination of the axes and our quadrants. That's what makes up those infinite amounts of points. Remember, it can go on forever in the y direction, negative and positive, and the x direction, negative and positive. So some of you may be familiar with that, but it's good to brush up on that always. Now, moving on. Now let's brush up on our coordinate pairs. So our coordinate pairs is basically what we do for every point that's in the coordinate plane, and it can be written as an ordered pair consisting of two numbers. So the first number is always the x value, and the second number is always the y value. So that means our coordinate should be some x, y. So for our basic examples here, if we wanted to graph the point 6, 4, we'd go again, like I mentioned up here, where our two positive coordinates are. So we would go to 6, up 4, and there is our point A. Same thing for B, negative 3, 5. This is our negative positive quadrant. So we go to negative 3, then we go up 5. There's my point B. And this should seem pretty simple, as this is something you should have recalled as we're going through this. I'll finish this off. We then have our 3, 0 here, which is point C. And then we have our point D, which is our double negatives, or our negative x and our negative y, in the third quadrant, which is negative 2, 6. So there is our point D. So at any point, if you are having trouble, always just pause the video, rewind, and you can always listen to it over again or ask any questions through the classroom page. So now let's move down. Now we're going to start defining our points and looking at them in a little bit of a different way. Our points, our lines, and our planes. So our point has 0 dimensions. So just a regular dot in space. You can't tell anything more about it. It's just a point, and it represents, like I said, a spot or a place in space. So 0 dimensions. All figures, or all shapes, any geometric figure, is made up of points. So for example, if I draw a square here, yes, I have my 4 points here to create it, but there's an infinite amount of points in between that can make up that square. So on the coordinate plane, just like we said, we use x comma y to represent a point. And then we name or label a point using a capital letter, which we were just doing. So for example, a point E, we'll give a coordinate, say it's 1, 7. So that's how we would label our point. Next, we have our line. A line has one dimension and just length. So if we take a look at our line, a line is a collection of points. So down here it says it's between any 2 points, there is exactly one line. So for example, this line here, here's 2 points. Let's say we have A and B. Now, these 2 points made up this line, but this can go on forever out to the right and also out to the left. And we could also draw an infinite amount of points. So once again, a line extends infinitely in both directions. So how do we label a line? We usually use a script lowercase letter. So for example, if I had this line here, oops, let's get back up to the top. So if I go back to that, say I draw this line here. If I wanted to give it a label, let's say it was line L. Usually it's followed with a script lowercase letter. So line L, maybe line P, lowercase p. Okay? We could also label it using the 2 points. So for example, that line I drew up here in this area here was line AB. I had the 2 points A and B. I connected them to create a line. So I can call this line AB. So the way I would do this is I would write my points A and B, and I draw a line on top of it with 2 arrows. It's important that you have the 2 arrows because we're going to get into something else where you need to specify if it has 2 arrows, 1 arrow, or no arrows on top. Now, moving on, we have our plane. So what is a plane? A plane has 2 dimensions and length and width. So what is a plane? So basically, say I have this rectangular looking plane here. You can measure length and width. It's not an infinite plane. Here, we can name this in 2 ways. So usually we use an uppercase letter instead of a lowercase letter here. So if this is plane M, say it's plane M, capital M. Make it a little more script here. So if we had a capital M to label this plane now, using 3 non-collinear points that lie in the plane. So non-collinear we're about to get into, so meaning they are not in a straight line. That's what non-collinear means. So say we had 3 points in here labeled A up here, we had a B over here, and a C over here. We could call this plane ABC. That's totally acceptable. You're more likely to see it labeled by the name of a plane with just 1 letter, but that's totally acceptable. So now, where do points, lines, and planes exist? They can exist anywhere. Anywhere in space, just like we were saying above for all of these. And we're going to be taking a look at a lot of these in the coordinate plane. Okay? So now let's move on. So now let's define collinear, non-collinear, and coplanar. So first let's look at collinear. So collinear means it's 2 points or more on the same line. So for example, so if I have these 3 points here, let's say it's point D, E, and F. These can all be connected in a straight line, meaning it goes on forever in both directions, and it doesn't stray off of this line at all. There's no random points anywhere. So that means they're collinear. So for example, something that wouldn't be collinear would be something like this. Say point E was up here, and we had D, E, and F. We would say that D and F are collinear because they are on the same line. E is not collinear. So moving on to non-collinear now, I basically just described it, is that it's 2 points that are not on the same line. So, say I have points A and C here. I'll just review this again. These points are collinear. Now, if I have, say, a point R up here, that's no longer collinear, okay? A and C are collinear, but not A and R or C and R, okay? So it's either they're on the same line to be collinear or not on the same line, and they're non-collinear. Now, coplanar. I'm sure you could apply the definition of collinear to the definition of coplanar. So coplanar, let's say I have another plane here. Say I have points A, B, and C. So these points are coplanar. They're points that lie in the same plane. So if I had a point outside the plane, point F, that would not be coplanar. So points A, B, and C would be coplanar. F would not be. It's not on that plane. So pretty simple and straightforward. Just remember, collinear and coplanar means same. Non-collinear means there's something that strays off. So now let's take a look down here. Collinear and non-collinear applying to equations of lines. So we have points G, 1, -1, and H, 3, 3 that lie on the line y equals 2x minus 3. So determine whether the following points are collinear to G and H. So G and H lie on the line y equals 2x minus 3. So that means if I plugged in either one of these points G or H into this equation here of a line, that means that the equation would work. So if we did, let's do test point G. So if we did 2 times 1 minus 3, so I plugged in my 1 here for x, I get that this is equal to -1, which is my y value here. So that means yes, I just proved what we were saying up here is that these are collinear or on this line. So now, to do this, what we have to do is we have to plug in these points now into the equation to see if it works. So let's test this out. So for example, I will tell you that this first one is collinear, and I will show you why again. So this has to be true. So if I plug in my x value 0 into this equation, y equals 2x minus 3, 2 times 0 minus 3 better equal -3. So if I do 2 times 0, I get 0 minus 3, which equals -3. So that is collinear. So now let's show an example that doesn't work. That's not collinear. So say I have point M with 10, 16. So once again, I'm plugging into that equation of the line to see if it works. So my x value is 10, and my y value is 16. So if I plug both these in, where x and y go, back to this example here, 2 times 10 minus 3 should equal 16 to be collinear. So 2 times 10 is 20, minus 3, 16. Wait a second, 20 minus 3 is 17. That's not equal to 17. 16 and 17 don't work out, so this is non-collinear. Okay, so we get the point. You can pause the video here, and you can practice the next two. So now let's continue here and go over those examples. So on number 3, once again, we're testing if they're collinear. So that means we have to plug this point in into this equation of the line to see if it fits on that line. So if we plug in -3 for x and y for -8, it should work out in the end to be the same thing on both sides. So if you see here, we plugged in -3, 2 times -3 minus 8 better be equal to -8. And we see when we follow through with our work that does not work here. -8 does not equal -9, so these points are not on this line. Same thing goes for number 4. So we plugged in -35 for x, -67 for y, and we see that that does not work out either for both sides of the equation. They're not equal, so they are non-collinear. So now on to the last page. Now we have some modeling with drawing and some joined together questions about planes, lines, and anything with collinearity or coplanar. So if we look up here at this model, we see that it says draw and label a figure for each relationship. So up here it says line K does not intersect plane M. So this picture would look like this. We drew a plane here, M, and all we're doing is drawing a line that doesn't intersect it. Same thing goes for here. Line T intersects the plane at point S. So this line, I know it's tough to see, is going up and down through this horizontal plane. So it goes through at some point S, it goes up and down, goes through the plane. And now for our last situation here, we have planes R and S intersecting at line M and N. It's a little difficult to see, but here's our plane going up and down. Here is our plane going left to right or horizontal. And then we have that line that cuts through MN. So you have to really use your imagination here to draw pictures, but once you start practicing these, the pictures start to come easier. So let's do these. So here we have lines M and N intersecting at point Q. So that means I need two lines, one's M and one's N, and they're intersecting at a point Q. So here's my line M. Here's my line N. Now, they intersected here at some point. And again, the point that it's intersecting is Q. So we drew what we needed to for this situation. So now this applies for number 2 to an example we did up top. Points R, S, and T are in plane M, but point W does not lie in plane M. So that means these 3 points here are in the plane M. So these 3 points are coplanar points. So let's show our plane M here. So we have, remember, capital script letter M. And points R, S, and T are in the plane. So they're coplanar. So we could really draw them anywhere. R, S, and T. And then it says point W does not lie in plane M. So all we got to do is draw this point outside of the plane somewhere. Number 3 says that plane M contains line N and point S. So pretty straightforward here. We have a plane M. Let's start out by drawing that. Plane M. And then it says it contains line N. So let's just draw some line in here. This line is right on the plane. It lies right on top of it and it goes flat. So we have line N. And then we have some point S that's also in there. So it's a pretty straightforward drawing. Don't think too complicated. Just read it as it is and start underlining. And then our last one might be a little bit more difficult to see. We have lines J and E are not on plane M. So we have 2 lines we need to draw. But they intersect plane M at X. So first things first, we start out with our plane M here. So lines J and E are not on the plane. So if they're not on the plane, that means they have to be kind of a 3D line. They have to go up and down. So let's just say that's line J. Then we have another line that's not on the plane but intersect at X as well. So we have another line X that's going up and down and they intersect at point X. So picture this box here down below. So if we look at this, for example, pretend we have a line that goes through the top of the box, another line that goes through the top of the box. They just happen to intersect at that point X. So they're not on the plane, they're just going through it. So if we continue on to our last part, we have a picture of a cube here. It looks like a rectangular prism. And then it asks a few questions. It says, are points H, J, K, and L coplanar? H, J, K, and L. So let me zoom in on that a little bit. H, J, K, and L. So yes, these are on this top plane here, right? They're all on it. They're on the edge, but that's still considered on the plane. So the answer is yes, these are coplanar. Name 3 lines that intersect at X. So remember our labeling from before. So what lines intersect at X? We have one line here. So that's line WX. So remember to label with 2 points. So we have line WX. We also have line, let's see here what this point is. XY. So we have the same thing going on. It intersects at point X. Here's our other point of the line. So we also have line XY there. Then finally, we need one more line, and that would be line KX here that goes up and down. They all intersect at point X. And our third question, what points do plane W, X, Y, and Z and line HW have in common? So let's look at our picture here. Let's use a different color. So if we look at this plane here, we're looking at WXYZ. So WXYZ is this bottom of the box here. So that's our bottom. And then we're also looking at line HW. So here's line HW. So this line HW is going up and down. And what do they have in common? The only thing they have is that point W, right? They meet there. This line touches this plane at point W, and that's the only thing we can see. So they have point W in common. Then our final question here is, are points W, X, and Y collinear? So where's my points? Let's use one more color here. So I have point W down here. I have point X. And my point Y, which is over here in the corner of the box. So are these collinear, meaning do they lie in the same line? That would not be the same line. A line is straight. This is not the same line. So there's 2 lines here, or actually they're not lines, they're actually line segments, but they're definitely not collinear because they're not on the same one. So the answer would be no, they are not collinear. So that's what we have for that. If you need to rewind and go watch some key spots, you can go ahead and do that. And then also, if you want to take a look down here, we have some examples of things that you're using points, lines, and planes in that you might have heard of in other places. You have some things going on with constellations and the stars. That could be something you could look at for collinearity, I should say. There's 2 points on the same line. It's something cool to look at. And then also, I'm sure you guys have all played the game Battleship. It's something that's pretty common, and you don't even know you're doing it. So that's a great example of points on a plane. Other than that, that's all we have for today, guys. Great job, and remember to rewind or rewatch if you have to.